The light that we see from the sun is just a small part of the electromagnetic radiation that's given off by the sun. This radiation contains a wide spectrum of wavelengths, but we are only sensitive to the visible wavelengths. Depending on what happened to the light before it arrived at an eye, some of the wavelengths do not reach your eye because they're absorbed and filtered in the atmosphere. Different colors are associated with different wavelengths. In the atmosphere, a beam of light bounces off of millions of molecules, which causes scattering. Scattering sends different wavelengths off in different directions. The brightness of a sunset depends on perspective. Since molecules are so small, they typically scatter the smallest wavelengths first, like blue. This is a very basic explanation of why the sky is blue during the daytime. Blue, which has a smaller wavelength, scatters more. We've seen this before when we learned about rainbows and prisms. When the sun is setting, there's a lot more distance that light has to travel through the atmosphere. Because of that, the light has a lot more room to scatter. The blue and colors on the smaller wavelength end of the spectrum scatter a lot more away from the eyes. Because the red light scatters less, it can go more directly towards the observer.
This type of scattering can be described by Rayleigh scattering. This is scattering from the atmospheric gases. It happens when the wavelength of the light coming in is larger than the particle causing the scattering. The scattered intensity is inversely proportional to the wavelength, to the fourth power. This means that the smaller the wavelength, the more the scattering. Dust and pollution in the air actually dampen the effects of a sunset. This is because the particles that are in the air absorb some of the light rays, which lower the clarity of the sunset. This can be explained by my scattering, which is scattering from pollution, dust, smoke, water droplets, and other particles found in the lower part of the atmosphere. It happens when the wavelength is smaller than the particle causing the scattering. It does not depend on the wavelength, and it scatters all wavelengths equally. My scattering dims the sunlight and makes the sunset less intense. Here in San Diego, we get some absolutely gorgeous sunsets. But why does it seem like they are so much more brilliant in the fall and winter? This has to do with the fact that the air is typically drier and cleaner during those seasons. These conditions allow for the light to be less affected while it's on its path. On an airless world, like the moon, the sun would not look any different than at any other time. But since we have the atmosphere, we get the beauty of a changing sunset. The atmosphere almost acts as a prism, with the light having to travel through about 1,000 miles before the sun dips below the horizon.
When the sun appears progressively lower and lower on the horizon, its light needs to pass through more and more of the atmosphere to reach our eyes. One thing you may not realize is that by the time you see the sun setting, the sun has technically already set, and the atmosphere bends the light to make it appear as though we are still seeing the sun that's there. This can explain why if a person times the sunset, it will be slightly longer than the 120 seconds that is expected because of the refraction in the atmosphere. One other interesting thing about sunsets is that despite the red appearance, there is still blue and green light coming from the sun, but these shorter wavelengths refract slightly more than the lower frequency ones, so the reds come in at a shallower angle than the blue and greens. At a given location, the green that reaches the eyes will have started out slightly above the red, and it will reach the eye at a steeper angle. The blue light tends to be a little bit more bent than green, so it's scattered out of sight. This green light will appear to land above the red, and if you're watching a sunset from a space that has a clear path to the horizon, there will be a slight region just above the horizon, above the red sun, where only a shorter wavelength of light is visible. This will allow for people to be able to see a separate region above the sun that appears yellow, green, or even blue. This will only be visible for flat areas where the pollution is minimal, and it can be known as the green flash.
Sunsets make our lives more beautiful by showing us that physics works in everyday life, and it is the combination of many different topics that gives us these experiences.
So, take some time and look at the sunset, because so many different factors go into creating a beautiful sunset. It's not something that we should take lightly.